Hi, everybody. Oh, I gotta turn the music off. Here, hold on. I don't know why YouTube is giving me an error that says the current resolution is unsupported. It seems to be fine. So I guess we'll just go with that. No, it keeps popping up. What is this? I haven't touched anything. Did I touch? No, this looks fine. I don't know what's going on. YouTube being YouTube. So it looks like there's some questions in the chat that I can answer. Now, I can't answer the question about the exam specifically right now because I still have people taking the exam. And that is one of the exam questions. But what I'm going to do is I'm going to just change the equation and change the substances and change the numbers, and then it's the same question just with different stuff. And I could do that. That's totally fair. I just don't want to give away this is how you do this problem. Let's see here. How do you know which bonds are single, double, triple, or non-bonding? Okay, so let me zoom this in, actually, so I have more space to work with. So on Canvas, I have a question that'll be like, draw this molecule. That's not the drawing tool. Let me get the other color. I don't know, I'm just drawing a molecule that I know has a triple bond in it. And it'll say how many single bonds, how many double bonds, how many triple bonds, how many non-bonding electron pairs. And so what you want to do is you want to draw the Lewis structure. And the way that you do that is by counting electrons. So carbon gives you 4. Each hydrogen gives you 1, and there are 3 of them. This carbon is 4, and this nitrogen is 5. And so the total here would be 4, 8, 13, 16. And so what I want to do for this, so the first atom list is always the central atom. And so what's going to be connected to that C is going to be a bunch of H's. Oops, I don't want to draw all these lines yet. Hold on. So we've got H's connected to them and a C connected to it because this is all listed in order, right? And then I got this N. Where's the N going to go? It's probably going to go over here because it can't connect to the C. I've already got 4 things there. So now what I would do is I would then bond everything. So that's 10 electrons, so there's 6 left. And then I go and fill an octet, so I would start by going here. Well, I'm out of electrons. Now I'm going to move stuff in so that we can get an octet on this carbon here, because it doesn't have that. So I'm going to move this pair in and this pair in. And that's going to look like that. And there you go. That's the correct structure. So this is just an example structure that I came up with. But the general process for how you draw any Lewis structure is the same. So remember that the steps are count valence electrons. And once you've done that, make a framework or a skeleton or whatever. And we'll say framework around central. That's the worst letter C I've ever drawn. Central atom. And then you want to get octets on the outer atoms first. And then put leftover electrons on the inner atoms to give them an octet. And then finally, you want to do multiple bonds to satisfy any octets that are left over. So central atom almost always the first. Yes. So the only exception to that is if you have hydrogen first. Hydrogen can never be a central atom. H coming first is a special designation for an acid. which you saw in the section about acids and naming. We don't really talk about acids in 140 other than just naming them. You're going to see them a lot in laboratory stuff because acids are a very common compound. But we will talk about acids in excruciating detail in 163. Like, that's pretty much the entirety of 163 is acid-base equilibrium. Where we get to bust out the quadratic formula, and you're like, holy shit, I didn't think I'd need this ever again. Nope, you need it to solve acid-base equilibria. Okay. Alright, so that's a Lewis structure. That's how you do that. I think that I put in 2 on the exam because I do want you to draw Lewis structures. Unfortunately, there's no way for me to really assess your drawing, so the best way that I came up with was to count how many bonds of each that you'd have. And so what you would do for this question is you'd go, okay, I have a single, 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 single. So number of single bonds would be 4. I have this guy right here, so number of triple would be 1. And then this right here, the number of non-bonding pairs would also be 1. And so I want you to just tally up all of the features of the molecule, because if you drew the molecule differently, you'll get different numbers of these, and then I'll just know immediately that, oh, that you drew the wrong structure. You didn't follow the rules, that sort of thing. So that's the whole point of those problems. I'm not going to make you go find Chem draw or draw something on like ISIS draw online or whatever and then upload that. Like that's ridiculous. Double bonds would be 0 in this case, yeah, because there are none. Alright, let me do Danielle's question here, but I'm going to pick a different problem. I ran out of space. Hold on. Image size. Let's see here. Not image size. I want canvas size. I always get those mixed up. So anchor at the top, and I want the height to be, we'll make it 500% bigger. Oh, right, I forgot about that. I always forget this part. Layer. I want backdrop to be white. Boop. And then new layer, and then green. And then this can go away. Okay, cool. So let me do a different question than that. Let me just open the big book of chemistry problems here that I have. This is actually the old 140 textbook that we used to use. And I want chapter 10 in this. I need something with 2 reactants. Yeah, that'll work. Okay, so I'm going to just make up an equation here. If I could click on the thing. There we go. So CO, NaCN, Na2CO3. Oops, hold on. Plus charcoal plus nitrogen gas. And so we got to balance the equation first. I don't know why I didn't just write this in here. 3, 2, 4. Yeah, that's good now. All right. And so we'll just say we have 10 grams of carbon monoxide and 10 grams of sodium cyanide. And we'll say how much sodium carbonate can be made. And so for this type of problem, the key point to note when you are looking at this problem is to go, oh, this is interesting. I have 2 starting masses. And so whenever you see that I gave you 2 starting amounts for your reactants, you know that this is a limiting reactant problem. And so what that means is you got to do it twice and use the smaller value. That's how much forms. So what we're going to do is we're going to say, okay, 10 grams of carbon monoxide and 10 grams of sodium cyanide. And so what we're going to do is we're going to turn these into moles of sodium carbonate. So let's do that. Grams carbon monoxide, moles carbon monoxide. So those cancel out. And then I know that moles of carbon monoxide can be turned into moles of sodium carbonate. There's a leaf blower directly outside my window, and I'm like, seriously, it's pouring rain. Why are you doing this to yourself and me? All right. 1 mole of CO is 30 something. 30.01. And then 3 moles of carbon monoxide is 1 mole of sodium carbonate. According to the balanced chemical equation up here, there's my 3 and there's my 1. So 10 divided by 30.01 times 3. So with 10 grams of carbon monoxide, I can make 0.111 moles of sodium carbonate. Now we'll go down here and do the same thing with sodium cyanide. Sorry. So we'll turn grams into moles. And then we'll turn moles of sodium cyanide into moles of sodium carbonate. And this one is 2 to 1. And I don't even have the slightest idea what this is. There we go. Len check. NaCN. 49.01. I didn't cancel these out. So 10 divided by 49.01 times 2. It's going to be remarkably close, and I just sort of picked a number. All right. So 10 grams of carbon monoxide will make 0.111 moles of sodium carbonate, but 10 grams of sodium cyanide will only make 0.102 moles. So this is the smaller number, which means that this is the limiting reactant. And so we are going to use that number to continue. The other reactant is in excess, and so we'll cross him out. Don't need him for the calculation. And so what mass of sodium carbonate would be made? Well, since the limiting reactant controls how much stuff we produce, we then take the number of moles that we'd get. We'll go moles sodium carbonate, grams sodium carbonate. And in a mole there are, I don't know, Na2CO, oops. 105.99. So the mass that we produce is just that times 105.99. 10.8 grams Na2CO3. So the tricks for a limiting reactant problem are, one, you got to recognize it's a limiting reactant. So remember, the way that that's done is to see that there are two reactant masses given. Then you convert both of them to moles of the product that the answer wants you to do. So in this problem that I made up, I said, how much sodium carbonate can you make? So we're going to turn both of these quantities into moles of sodium carbonate. Once you've done that, you choose the one that's smaller. It's the limiting reactant. The excess reactant produces more because these calculations all assume that the other component doesn't exist. It doesn't matter. We're just doing the theoretical calculation, remember. Once you know which one's the limiting reactant, you can then turn it into a mass, which we did here. So that's how you do a limiting reactant problem. For the percent yield problem, let's see here. So again, I'm just making up different examples because I don't want to give away exact solutions to the problems that you're working on for the people who are still taking the exam. I had a bunch of people say, hey, can I take it on Tuesday? I was like, yeah, sure, whatever. Let me try and think of a different problem for this. So, actually, let's just go to the big book of problems. Big book of problems. Big book of problems. I'm trying to find a good one. We just do ammonia again. No, we did ammonia in class, so. How about water? Let's make water. I like water. If the exam marks you wrong because you were off by 0.2, yeah, email me because that should be close enough. The problems thresholds that I set should be within 0.3 of the or 3 on the last digit. So whatever that ends up being. If the answer goes down to the thousandths place and it's 20.005, then if you put 20.1, you're too far off. It'll mark wrong and I'll say, sorry, you're wrong. But if this was the expected answer, sorry, 20 something, and you got this, that's close enough. This, however, if you got this, that's not close enough because you have the wrong number of sig figs, so you're in the wrong position anyway. In some weird cases, Canvas will still mark this right. But if you land on that one in whatever chance edge case, then there's not really much I can do. Okay, so for this problem, let's suppose that I put in, I'm going to say we put in 20 grams of hydrogen, and my percent yield for my water synthesis was 74.8%. How much water is produced in grams. So, what you would do here is you would need to figure out the theoretical yield. How much can you theoretically make with 20 grams of oxygen? So, 20 grams of H2, or I'm sorry, 20 grams of hydrogen. So we'll turn grams of H2 into moles of H2, which is a lot of moles of H2. Then we'll turn moles of H2 into moles of H2O. And then we'll turn moles of H2O into grams of H2O. All right, so 1 mole of water, or H2, sorry, is 2.016 grams H2. This is 2 to 2 from the balanced chemical equation up here. And then 1 mole of water is 18.02. We're going to make a lot of water. Who's thirsty? 2.016. 178 grams of water. 79, actually. And so this is the theoretical yield. So in theory, you could make 179 grams of water out of 20 grams of hydrogen. The remainder is oxygen. You just need to put that in there. But let's suppose that our actual yield only gave us a percent yield of 70. I forget what number I wrote. 74.8. And so I know what the theoretical yield is. I just got to solve for the actual. So the actual yield would be 74.8%. That's supposed to be a percent. Let me fix that. Divided by 100% times the theoretical yield. So that would be 0.748 times 179 grams H2O. So if I had a percent yield of 74.8, I would have only instead produced 134 grams H2O. Now, with these types of problems, there's a different type of percent yield problem where I give you the actual yield instead, and you tell me the percent yield. So instead, in that case, you would solve for this one, and you would know this number. And that's trivial. You just take the actual yield I gave you, divide by the theoretical yield that you calculate, times by 100% to get the percent yield. For the problem that Maple posted there, what volume in milliliters of this molarity calcium chloride is needed to react? There's actually a typo in that problem. And so what I'm going to do, I fixed the typo, but because, let's do, I don't know if this will actually work. Oops, I just want the problem. I hit paste here. That didn't do anything. Oops, that's not what I wanted. I made everything big. I want to print screen this. And we're going to just go like that really fast just to make sure that what pops up is not my desktop with all of my files on it for teaching. That was a little tiny, wasn't it? Oh, there we go. Let's just do this. Okay. So right here, we're going to take this and just paste it over here. And then I can just take the rest of this and go... That didn't work. I don't know why that didn't delete. Am I on the wrong layer? Layer. Yeah, I am on the wrong layer. Bah. Deleted. Okay. Delete layer. Yes. Okay. So the only reason that I'm actually doing this is because right here in this problem, there's a unit missing, and it's right in here. That's not the pen, that's the selection tool. And of course I'm not drawing on the right layer, because why would I be drawing on the right layer? I want to draw on this layer, so now that I can draw on top of it. There we go. So 210 moles per liter. This is fixed on exam 2. I can't blame Canvas for that one. That one's definitely my fault. So when I am programming the formulas in here, I have to use variables in the statement that I write. So I don't write this statement that you're seeing right here. What I end up typing in is what volume in milliliters of M1 calcium chloride or whatever is needed to react completely with V1 milliliters. And so I had to actually type in the units afterwards, but sometimes I will interpret my variable as the unit. So I apologize for that. Excuse me. Let's go ahead and solve this problem. What I'm going to end up doing here is I'm going to just delete this layer. Delete layer, so we'll get rid of that. And then let me erase this guy. And so I'll make up a different problem here for... what did I just do? Oh, crap. There we go. Okay. So let's react... Let's react... Oh, I don't want writing green. Let's react barium hydroxide with HCl. Now we gotta balance the equation, so that's gonna be, this is a 2 for sure, and this is a 2. Okay. And so what volume in milliliters of... let's see here. Okay. So I'm going to say that we have, for barium hydroxide, I have... We'll say that. And I don't know its volume. But for my HCl, I have 1.2 molar, and we have 50 milliliters. And I want to figure out what volume of this reacts. So remember that molarity times volume equals moles, and then you can turn moles of something into moles of something else, ... and go to wherever you need to. I need more water. That's what I need. So I'm going to multiply the two volumes that I have, or I'm sorry, not the two volumes, the two values that I have. So that's going to be the molarity of HCl times its volume, or divided by its volume. I don't know what I'm saying today. The molarity of HCl multiplied by the volume of HCl. But I need this to be in liters. There you go. So if I were to punch this in the calculator, I would get the number of moles of HCl. It'd be 1.20 times 5. But what I'm going to do instead is, I know this is moles of HCl. This is the only unit that's left, so I'm just going to keep the calculation going. And so this will be moles of, what are we turning this into? Barium hydroxide. And once I know the number of moles of barium hydroxide, I can then turn this into a volume by using molarity. And I want to use the molarity of the barium hydroxide. Right there. In the middle column here, I want to do the ratio between barium hydroxide and HCl. And nothing goes in the space down here because I'm just multiplying by a volume. There's no units, so you don't put anything there. And so I'll multiply all these things together. 1.2, 0.05 divided by 2 times 0.525. And what I get is I get 0.0571 liters, or 57.1 milliliters. So it'd take 57.1 milliliters to totally neutralize it. So that's a problem similar to the one that Maple posted. Do note that there is a typo in there on quiz 9. If you took the quiz early enough. So somebody emailed me pointing out the typo, and I fixed it, but what Canvas does is it only applies the fix to people who haven't seen it yet. So if you've done the old version of the problem, it won't have that unit there, and that's what it's intended, is it's supposed to have an M there. And again, I'm just doing I'm doing different versions of these problems so that I'm not giving away the exact problems on the exam or the final. You guys have probably figured out I'm reusing these questions. There's a large pool of questions because I made like 4 or 5 different versions of them, but I don't need to reinvent the wheel. Oh my god, what is going on in the parking lot? What the fuck, guys? Oh, they've chosen today to be the day that they chop down a tree, and so somebody is like vacuuming up a bunch of mulch, and that has set off every car alarm in the parking lot, apparently, because it's loud. Except for mine. My Jeep is like right there. I don't even know if it has an alarm, to be honest. Okay, I'll try and ignore it. Hopefully you can't hear it. Let's see here. Stella, I don't know what you mean by blank, 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 blank. You have to be more specific for me. Unless you meant the problem that we did before, which was this one up here. So if you meant a limiting reactant problem, we did one of those before, so you can just rewind the video. I actually didn't know that you guys could do that. Until rather recently. I have this thing in the YouTube viewer. Where is my viewer? So I can actually see what stats are going on in the video in the stream set, not stream settings, analytics. There's a button that says playbacks. And apparently every time the videos are loaded, including page refreshes, it tallies that. And so you can apparently like pause the video and just go back in time a little bit. And then I guess you're just behind for a little bit, which is fine. Either that or what this is saying is that everyone's connection is terrible. And that people are constantly having to re-access YouTube because it keeps cutting them off or something like that. Oh, yes. What one last noise could we add to the mix here? Let's see here. Hi. You don't have any questions, so you can say hi to them. Maya wants to thank everybody for a good quarter. She sounds so sad, but she's actually just whiny. Huh, Maya? She wants me to pay attention to her and not you guys. Are there other questions that people would like answered? Let me know. I think what I'll do is I'll put this back up here. Oops, that's the slides, which there aren't any. There are no more slides. We're all done. Ooh, you can watch in double speed? I didn't know that either. That's kind of fun. Then I sound like this. I'm talking really fast. And everything goes really quickly, and my pen goes all over the screen. Something like that, right? Okay, so I'm going to put this back up. I'm going to turn the music back on. I'm going to let it sit for like 5 minutes or so. And you can just type in any more questions that you have. I'm going to hug the cat because she's just sitting here wanting me to do that. So, let's see here. Alright, this is my good idle music here. Alright, I'm going to mute my mic, and I'll check back in like 5 minutes. Actually, before I go, just really quickly, in case the stream is done and people leave, please note that the final is on Thursday. Obviously, you probably know that. The lab worksheet is also due on Friday, but I also need anything NQA that you have turned in, or haven't turned in, I guess, which would be NQA. I need it by Friday. If I get it after Friday, there is a possibility that I won't grade it in time. I will try to grade anything that is sent to me, but once I have everything done or think it's done, I send the grades off, and once grades are sent off, I can't change them. So just be mindful of that, okay? Punch any questions you have into the chat. I'm going to hug the cat, and I'll be right back. Alright, I am back. I assume that the cat is happy because she walked away when I set her down. Although she's now standing in the hallway and probably wants more attention because cats. That's what I want to click on. Let me just scroll down here. Alright, let's see what we got. What mass of calcium nitrate in grams is contained in this volume of this molarity solution? Let's see here. So what we're going to do is I'm going to instead change calcium nitrate to something else. So let's do... What? You know what? This is kind of a silly way to do this. I have this really nice text button here. Let's see here. What? Oh. Oh, I know exactly what I was doing last time I did this. I was doing stuff for the stream for my Twitch TV stuff. Aerial regular? Not narrow. Regular. There we go. So let's see here. What? That's too tiny. What mass of Ag Cl? Or actually, no, that's insoluble. Hold on. Ag, okay, NO3. I can't subscript, unfortunately. What mass of HNO3 in grams is contained in, I don't know, this many point whatever milliliters of a 0 point numbers solution of AgNO3. There we go. That's how I write your problems, by the way, is I'm just like, what number should I use? How about those numbers? That's too many numbers. I literally hit every number on the keypad there. But I'll just be like, meh, whatever. Whatever my hands hit, that's the number you get. Okay, so why isn't this working? Am I on the wrong layer again? Photoshop, why? Okay. I mean, that's important if you're an artist, but I'm just using this for typing and stuff, so... Okay, so to figure out the number of grams of something in there, you need to know the molarity and the volume, and remember that molarity times volume equals moles. So if I take my 0.798 moles of AgNO3 per liter, and I times it by the volume in liters, that will give me the number of moles of silver nitrate. And then what I could do is I could multiply that by the mass in grams per mole. Why is Photoshop getting slow now? Okay. EgNO3. 169. And that should be the mass of that. 0.798 times 0.6876 times 169.87. And I got 93.2 grams AgNO3. No Windows, I do not want to update. Go away. There you go. 93.1 is close enough. Canvas would accept that. Okay, I gotta break out the text box again for this one. So, let's see here. Could you go through writing a chemical equation for my written out chemical reaction? So let me think of a chemical reaction. I don't want to keep using silver stuff, but this is what I'm thinking of. Silver acetate mixes with sodium bromide to form... I've already forgotten something. So silver 1 acetate to form silver 1 bromide and sodium acetate. So something like this. This is probably how photography paper is made. Photography uses silver bromide, or it used to, I should say. So when I say photography, what I mean is in the before time, when people actually like printed stuff onto paper. Photo paper is a silver bromide compound that is photosensitive, which means that when you expose it to light, it reacts and it turns a different color when exposed to a fixer, which is some sort of sulfur compound. I don't remember. Sodium thiosulfate or something like that. I took photography in high school, and it's one of the coolest classes I've ever taken. I recommend everybody take photography because you learn so much. There's lots of chemistry in it. There's lots of art in it, and it's just really fun to play around in the darkroom with your friends. You know, and when we can eventually go back to the college. Although I don't know if we have a photography darkroom anymore. Everything is digital now. Anyway, so what we're going to do, we're going to take each of these compounds and we're going to try and write their formula and then make an equation out of it. So first we want to look at silver 1. So that's that. And then acetate would be this. What's the difference between silver acetate 1 or 4? So what does this thing do? That little 1 there? That means it has a +1 charge. And remember something like this. The Roman numeral tells you what the charge is. So putting these two things together, I have one positive, one negative. This is easy enough. Oops. Oh, I kind of picked them all with +1 charges. That's okay. Sodium bromide. So sodium is that. Bromide is that. Forms silver 1 bromide. And you could probably see how this works. And sodium acetate. Now, if I gave you something different and I don't know, say like the ions that you formed would be instead that, remember you got to balance the charges, so I'm going to need more iron and more sulfate so that the total charge is equal on both sides. So here when I hit the wrong thing. Here when I look at the charges, I have +6, and when I look at the charges there, I have -6. So those are balanced. So the formula that they would all make together would be Fe2SO4 3. So that's how you construct equations out of those things. I think the one on the exam, what they have you do is you have to take the words and put them into the statement. Then you have to balance the equation. Then you have to put in the numbers correctly to show that you have the correct equation and that you've balanced it. What else do we got? Making grams into atoms particles. Yeah, sure. Let me scroll down. So let's see here. I don't know why I'm doing this way. I literally just discovered I can type shit. So, how many particles? Oops, not particles. How many atoms of carbon are in? I don't know. 1.5 milligrams of I don't know, oxalic acid. So something like this. I have to render the layer, so give me a second. I can hit Control L, right? No, I can't hit Control L. What is the command? F7. I would never have guessed that. Render layer, and I can draw over it. Boop. Okay. So, yeah, oops, that's not the drawing tool. Woo! Okay. So how many atoms of carbon are in the sample? So I have this many milligrams of that. Obviously, the first step that I'm going to want to do is turn this into grams. And then the next step that I'm going to want to do is turn it into moles, because that's what we've been doing all quarter, right? Try that again. And then from there, we could do a mole ratio to go moles H2C2 to moles of carbon. Because remember, you can do moles of one thing in the molecule. And then I could figure out how many atoms of carbon are in a mole, because I know the relationship between atoms and moles. So the relationship here is in 1 mole of anything, there are always Avogadro's number of those things. The relationship here comes from the balanced chemical, or not balanced chemical equation, the formula. In 1 mole of the molecule, there are 2 moles of carbon, because there's a 2 there. And then grams per mole we've done 60 million times, so we go to Lentech, H2C2O4 is 90.03. 0.00150 to Avogadro divided by 90.03. And so when I punch all that in, I get 2.01 times 10 to the 19 atoms of carbon. There you go. Uh-oh. Dropped the pen. Almost dropped the pen. No, I did drop the pen. There it is. So that's how you convert something. Oh, I disconnected, didn't I? Boo. Is it back? OBS hiccuped. Are we back online? Okay. How long is it down when it does that? Because I had no indication that I was offline until it popped up and said, "Hey, you're back." YouTube, stop it. Stop giving me this error message. It was refreshing for a few seconds, like a minute. Okay. Let me just walk through what I did again, just in case. So, first thing I did was I took my problem and I converted to grams, because that's where I want to start. We want to turn grams into moles. We'll turn moles of the molecule into moles of a part using the molar ratio, and then moles of anything can be converted to number of that thing. And so that would be atoms. And the relationship between atoms and moles is always Avogadro's number. The other relationships we have done in previous problems, so you recognize them. Okay. That's all I got. How do you do that backwards? You just set it up the same way. Except all of your units would go in the opposite orientation. So if you had this here, you could turn atoms into moles. And then you could turn moles of carbon into moles of the big thing, which would be oxalic acid. And then like that. And then you'd basically just be typing in all the numbers, oops, in the opposite spots. And so you would get the number that you started with when you punch it in the calculator. Now, whenever you're doing problems like this on the calculator, make sure that you're putting your parentheses around everything on the bottom when you multiply it all together. Some people do this. They say, oops, I hit the wrong thing again. I keep hitting that. Why would you put the zoom there? That's dumb. Some people say, oh, I do this times that number divided by that number times that number divided by that number. And that'll work too. You could do it that way. The other way to do it is to just multiply all the numbers on the top, push divided by, hit another parenthesis, and then multiply all the numbers on the bottom. That's what I do. Set up on lab question 20. Let me find. Which folder is it? This one. Lab 5. Hopefully that's not like buried deep in the procedure because I might not be able to answer it. Oh, it's the analysis question. Okay. So I could put that on the screen here. I gotta move this window first though because I can't get to PowerPoint or Photoshop if I don't have it. I don't want that because that's just chat. Where the hell is it? Oh, I've ruined everything. Hold on. I have to remove this. Let's try this one. Yeah, that's better. I can't even read that, so we're going to make it really big. All right. A lab tech needs to prepare HCl solution for a demo for 6th graders that shows how zinc reacts with acids. Which is more appropriate, 0.2 molar or 0.2000 molar? Okay. So, if you're doing a demo to show zinc reacting with acids, is there anything in that reaction that requires a high amount of precision? Or are you just doing something to make quantitative? Are you making quantitative or qualitative observations, I should say? So the point of this question is to get you to differentiate what type of experiment do you think this is that they're doing? Are the sixth graders going to use the results of this to make measurements, or are they just going to look at it? And then, based on what your answer to that is, which solution do you think is more appropriate? Because one of those requires a lot more work to make than the other. And this is actually something that we do in the lab all the time. When we do demos, we have solutions that are good to one sig fig because who gives a shit, right? We're not going to measure it afterward. We just want to see the pretty colors. And so I've basically told you the answer at this point. So there you go. So yeah, sometimes you do get to shortcut in chemistry. I remember once during a lab, I usually teach late night lab because I'm a night owl. And so I am in the laboratory from 5 to 7 p.m. And I'm the only faculty in the building for chemistry. And sometimes we run out of chemicals, and so I would go to the stock room because I can access all the chemicals and stuff in there, and I'd have to get more. And so one year we ran out of acid, and I had to dilute an acid to make more of it available. But the number on the bottle had only one sig fig on it. I was like, well, that's really weird. Why would we only have 1 molar H2SO4? And then I looked through the procedure and I was like, oh, this isn't actually used in the reaction. It's just a catalyst. So I turned 18 molar HCl or H2SO4 into 1 molar. But I just eyeballed it. I was like, I need about 1/20th, so 5 milliliters in 100, or 50 in 1,000, or whatever. So I did that, and then poured it in the bottle, and the reaction worked fine. And everyone's like, "Wow, you did that so fast!" And I'm like, "Yeah, I just estimated." Because sig figs, who gives a shit, right? If there's only one. If there was 5, then no, I had to go get out the pipette and stuff and make sure that I get it exact. But 1, you just have to be close, because 1.2 or whatever rounds to 1. Good enough. So that if you go into like a lab tech sort of position for industry or academics, that's the sort of thing that you'll want to do to save yourself some time, because some experiments don't need precision. Anything as a demo does not. These are all just things that I wish I had learned when I was a student, because I could have totally done the lab tech position. It's just following directions. And it's really good practice for chemistry. So, like, if you wanted to prepare all the solutions for all the experiments that are done in our labs at Everett Community College, you can do that by just taking 140. Like, it would be difficult because you're doing all the chapter or the unit 13 through 16 stuff just forever, but that's all you do, is you just do that. Those are the calculations you do, and then you have to also uh, wear like a breathing apparatus when you deal with the organic chemicals, because they can be overwhelming. Any other questions? Anyone else have anything? If not, I'm gonna go back and start grading your labs for lab number 4, because I finally have time. I had to get all the exams out of the way. I read the final last night, so you probably got an announcement about that. It's not available until Thursday, so don't worry about it. But I do have to grade your lab number 4. So that's my plan for the afternoon, is do that till I get hungry and then go buy groceries. How do you get the Roman numerals on the answer? Can you get more specific? I'm not really sure what you mean by the answer. Let me scroll down more. Oh, how do you get the 8 out of that? Let me rewrite that, because that looks kind of like... It looked like a 5 to me. There we go. That looks like a... That looks like an S. Alright, so how do you get charges? So it's 8 and not 7. Be careful. And the way you do that is you say, okay, well, what ions are forming out of these? So oxygen always forms a specific ion. What ion is that? Well, oxygen starts with 6 valence electrons. And in order to get it to an octet, I keep hitting that button, my goodness. I got to give it 2 more to make it O2 minus. So each oxygen is O2 minus. So I got a total of 8 minus. What must this guy be in order to have a balanced neutral charge on the whole thing? It's got to be 8 plus. And so what you would write this as is osmium 8 oxide. Whenever you do transition metals and they have a charge with parentheses, you're going to get that information from the anions. Because the anions that you put in here are always known. And the reason for that is they are in groups 4 through 8A, or 5 through 8A, I guess I should say. So they will always be a known -1, -2, -3 charge. If it's a polyatomic ion, you know it's charged because you can look it up on the chart. And then for the cation, which is the positive one, you can always solve for that based on what other information you have. I will always give you enough information to do that. Usually the things that we work with are just these binary guys. All right. Let me know if you have any more questions by putting them in the chat. Otherwise, we'll call it a day. So tomorrow is another review session scheduled. I don't really know if we need 2 of them. Is anyone who's currently here going to come back to the one tomorrow? I mean, sure, there is a possibility that you might have more questions. I could probably handle those by email. When we solve a chemical equation, does it have to be empirical? Okay, so some people might show up. So, okay. I'll put the stream online then and see. I'm going to be awake anyway, so it's not going to, like, oh, I don't get to sleep through it. I don't sleep in that late. I'm not sure what you mean by it has to be empirical. Do you mean like when you find the empirical formula? So, like, if I gave you a mass of carbon, hydrogen, and oxygen and said find the empirical formula, then yeah, you always get an empirical formula out of that. Yeah, I'll have another one. Also, what I'm not really thinking of, I guess, is that anyone who couldn't make it today, they might be able to make it tomorrow. So, because it is finals week, so I have no idea what other people are doing. They might have finals right now, which I think is dumb. Everybody should just have their exams open for an entire day, but I don't teach your other classes, unfortunately. I don't need this on the screen anymore. What do... Oh, okay. Yeah, running start and high school classes can be a lot to manage. I don't actually know how many classes you take while a running start student. I always thought it was just like one, maybe two. And then I know a bunch of students like got their high school classes waived. Like they would take pre-calculus and then my chemistry class, and I know that because they would always be doing the unit circle in 140. I'd be like, "That's not chemistry. That's the unit circle," and they're like, "Ugh, I hate everything about both of these things." I'm like, yeah, the unit circle kind of sucks. Yeah, I don't actually see how you could take both, given that they would conflict times. Like, although I guess now they might not because everything's online and you could just watch my videos whenever and go to the one that they have, which is almost assuredly on Zoom because Zoom's fucking everywhere and I hate it. This is so much better. I don't understand why everybody doesn't just stream to YouTube because it saves it automatically. Everybody can play it back. There's a text relay. No, we gotta use the Zoom program. Sorry, I'm being catty. I just really hate Zoom. I think it's a garbage program. And everybody I talk to who uses it hates it too, but everybody uses Zoom, so you know. It's like Amazon. Everybody hates Amazon, but everybody uses Amazon. Like, man, I want to have like a company that everybody hates but still uses. Like that sounds great. They will just begrudgingly give me their money. All right, if there aren't any more questions, oops, yeah, let's put this back on the screen. I'll leave the music playing for a few more minutes because we have like what 20 minutes left, 30 minutes left, 30 minutes left. So we still have time, but I do want to give one last shot for anybody who has questions here. I gotta find the window. There we go. So we'll get this going again, and I'll see if we get any more questions in the next 5 minutes, and we'll call it a stream. Oops, excuse me. If not, back in a bit. Alright, it looks like there isn't anything extra in the chat here, so I'm going to shut the stream down, and we will reconvene tomorrow for the last review session. It'll be the last time you hear my voice, unless you're taking 161. So I will see you for that. Have a wonderful rest of your afternoon, and best of luck studying. See you tomorrow.